Okay, good morning, students. As you know, this is Subodh Pandey, and you are floating in the world of physics along with me. So, in this topic, the topic is power of a lens. So, in this topic, we will discuss about what is power and when it is associated with the power, then what is actually mean. Okay, so let's get started. As you can see here, it is written that the power means it is represented by symbol capital P, and it is defined as P equal 1 upon F. It means simply you can say that the reciprocal the reciprocal of f. F stands for focal length. Okay, so if we know the focal length of any lens, then we can easily calculate the power of that lens. Okay, what does it mean? It means let's suppose the focal length of a lens is given, that your 2 meter. Okay, so if the focal length is 2 meter, then the power will be 1 by f. So 1 upon 2, it means 0.5. Okay, so this is basically the power of that lens whose focal length is 2 meter. Now, one thing you should remember that while using the formula P equal 1 upon F, it is very clear that F must be in meter. Okay. Now, what if F is not in meter? It is in centimeter. Then what will you do? Then in place of 1, we have to take 100. It means P equal 100 upon F. So here F will be in centimeter. So I hope that this is now clear to all of you. Okay. Now see a question based on it. If it is given that suppose F is 20 centimeter, so P equal, that will be 100 over 20. So 100 over 20, it means 5. Okay, so this will be the power. So in one word, I can say that the reciprocal of the focal length gives the power of any lens. Okay, now we will see the unit. The SI unit of power of a lens is obviously meter inverse, and it is also known as diopter. So in place of meter inverse, you can put diopter or capital D. Simply like here, it is 5D or it is 0.5D. So D stands for diopter. And as you know that the converging lens has focal length that is positive. Okay. And the diverging lens has focal length negative. So the power will be positive or negative depending upon the nature of the lens. Now one thing which I would like to recall you or memorize you, that you should always remember what, that if we have focal length. Okay, now what type of focal length? Let's suppose the focal length is given to you, and that is 5 or suppose 20. Okay, so if focal length is given to you, that is 20 centimeter, it is clear that the focal length is positive, because positive sign whether you use or you not use. In both cases, the positive sign is considered. But if we use the formula for the power, so power will be in that case 100 upon F. Why we use 100? Because it in centimeter. So it will be 100 upon 20. Okay, so it will be 5. Now if you write 5D, then your answer will be wrong. Why? Because in case of power, it is compulsory that either you put positive sign or you put negative sign. It means plus 5D, that is your correct answer. And if you write like 5D, then it may be wrong answer. Okay, it depends only on the observer there, or the examiner, you can say that by mercy he will give you marks, but actually that is incorrect. So the correct procedure is, whether it is positive, so you should place positive sign, whether it is negative, you should place negative sign while writing the value of power of any lens. Okay, this is the standard procedure. I hope that it is now clear. This is your next derivation, and this next derivation says that thin lenses in contact, and this is the formula which you have to derive. Now question is how we can derive this. Here, if you see the heading property, the heading is to two or more, whatever, but the thin lenses are in contact. Firstly, while we have derived the expression for the lens maker formula, in that case, you have gone through that we have one surface like this way, and we place the another surface like this way. Okay, when the, let's suppose this is first surface, this is your second surface, and when you add these two surfaces, then we get the lens. Now while the derivation, one point is very important, and what is that point? That point is the object O is kept in front of the first surface, and the image formed by the first surface, suppose that the I dash, will work as an object for the second surface. Okay, it means the image of the first surface will be the object of the second surface. The same concept we are going to use here. Okay, so what will we do here? Firstly, we will draw a single lens. Okay, so we have a single lens like this way. Let's suppose this is your lens. Okay, now as you can see that this is the vertical axis and this is the principal axis. Now you have to put your object. So let's suppose this is your object O, and the ray which moves from the object strike to the lens like this. Okay, and because this is a converging lens, so we get an image from the lens, and let the image be I dash. If the focal length of this lens, let be this one is f1, because it is the first lens, you can see clear. So this is your object distance u, and this is your image distance v dash. Why we are taking here I dash v dash? Because we know that some more thin lenses are in row, they are coming and just sit beside the uh, main lens. Okay, so it means we can simply say that the image of this lens, whose focal length is f1, will be the image, will be the object of the second lens. So in this case, for this lens only, we will use the lens formula, and the lens formula is 1 upon f equal 1 upon v minus 1 upon v. Okay, so in place of f, that will be f1, and in place of v, that will be v dash minus 1 by u. I hope that it is clear. Now one thing here you should remember, what? Here we are not using the sign convention, and the reason is so simple, because the formula 1 upon f equal 1 upon v minus 1 upon u is already derived with the help of the sign convention. Okay, and here we are proceeding that derivation. means that derivation is going on. It is a continuous process. That's why we are not using again and again the sign convention. Okay, so we can simply say that now we have to put our second lens. So let be this is your second lens. So if this is your second lens, suppose like this way, and it is in contact like this way. So this is very thin lens, as you can see here. This is the vertical axis of the lens, and the focal length be f2. So f2 is the focal length of the second lens, while f1 is the focal length of the first lens. Now, as I have told you that the object of the second lens will behave like the uh, sorry, the image of the first lens will behave like the object of the second lens. It means we can simply say that this I dash, this I dash is the image of the lens. This is lens, first lens. So this I dash will be the object of lens 2, whose focal length is f2. Okay, so it means in this case the distance of the object is taken as b dash. Now what? We have to complete the ray diagram. So the final image, we can say that we will get the final image I at a distance v. So for the second lens, again we are using the same formula. This formula we are using, that 1 upon f, so it will be f2, 1 upon v. V is the image distance, so it is taken as b, minus 1 upon u. U is the object distance, and I have already told you that the image of the first lens is the object of the second lens, so the distance will be b dash. Let be this equation first and this be equation number second. Okay, now what we have to do, because the two lenses are in contact, so we can simply add them. So equation 1 plus 2. So as you add these two equations, then what we get? We get 1 upon f, and that 1 upon f1, sorry, plus 1 upon f2. You can see here 1 upon f1 plus 1 upon f2, that is equal. So here you have to place equal, and one side 1 upon v dash minus 1 upon u. So 1 upon v dash minus 1 upon u, and other is 1 upon v minus 1 upon v dash. So 1 upon v minus 1 upon v dash. Okay, so here you can see that 1 upon v dash and minus 1 upon v dash, that will be cancel out to each other, and we have 1 upon f1 plus 1 upon f2, and this one will equal to 1 upon v minus 1 upon u. And 1 upon v minus 1 upon u is nothing but it is 1 upon f. So we can say that it is the focal length when the two lenses are in contact. Now what if there are more lenses are there, 3 lenses, 4 lenses, or n lenses are there, then in general we can simply say that we have to write 1 upon f equal 1 upon f1 plus 1 upon f2 plus 1 upon f3 dash dash dash, and whatever it means, if there are n lenses are in contact, then it will be n times 1 upon f. So I hope that this derivation is now clear to all of you. Okay, once again, just see here, thin lenses in contact. It means firstly you have to take first lens, draw the ray diagram. The image of the first lens will behave like the object of the second lens. Okay, apply the formula for the lens, that is 1 upon f equal 1 upon v minus 1 upon u. So for First lens, in place of f you have f1, in place of v we have v dash, because that is not the final image. Okay, u is u. For the second lens, the image of the first lens is the object of the second lens, and the image is v and focal length is f2. Now we are kept in context, so we have to add these two, and when we add, then we get like this way, and finally we get the result as 1 upon f1 plus 1 upon f2 equal 1 upon f. I hope and I believe that this derivation is now clear to all of you. What you have to do, you have to just practice yourself. Once you practice, draw the diagram according to the we can say the basic concept of the image formation, as uh, we already know. This is your example, work out examples. Okay, so here what is given, it is given that an object is placed on the principal axis of a concave mirror of focal length 10 centimeter at a distance of 8 centimeter from the pole. Find the position and nature of the image. So basically in this question what is given, firstly we will draw a rough diagram. The given lens is concave, given mirror is concave mirror. So this is your concave mirror, this is your principal axis, let be, this is rough diagram, and object, let be here, this is your object. The focal length f, that is your 10 centimeter given to you. Okay, and the distance of object is also given, that is 8 centimeter, and we have to find the position and nature of the image because it is a mirror. So we have to place the mirror formula, and the mirror formula is 1 upon f equal 1 upon v plus 1 upon u. Focal length will be positive or negative. For that, we have to assume that ray will move like this way. If the incident ray is moving like this way, then after reflection, it will intersect like this way, and this will be your focus. So you have to move in the opposite direction of the incident ray, so f will be negative, so it will be minus 10. I hope that this is now clear to all of you, because this thing I have already explained to you in the topic of sign convention. We have to calculate, plus and u is also negative, according to sign convention it will be minus 8. So it will be minus 1 by 10, it will be 1 by v, and plus minus to minus 1 by 8. So we can rearrange it, and we can write 1 upon v equal, this 1 by 8 will be positive on the other hand, minus 1 by 8, 1 by 10. Now what? 1 by v equal 1 by 8 minus 1 by 10. So 1 by v equal 1 by 8 minus 1 by 10. So 1 by v, that is equal, let's suppose the LCM be 80. So okay, so it will be 10 minus 8. So it can be written as 2 by 80 or 1 by 40. So 1 by v equal 1 by 40 or v equal 40 centimeter. So this is basically the position of the image formed. I hope that it is now clear. Now nature of the image we have to discuss. So as you know that nature is basically the position, or we can say at what position the image is formed, that exactly tells about the nature of the image. As you can see that here v is positive. So v is positive, what does it mean? As I have told you that this is your mirror, and whatever the distances are in this direction, means opposite to the direction of the incident ray, that will be negative, while in the direction of the ray, that will be positive. And here V is positive. It means the image of the mirror, this is your mirror, and image must be this side, or we can say that will be polish side. And if the image is at polish side, so it will be virtual. So it will be virtual. I hope and I believe that this question is now clear to all of you. Okay, this is your second question. So in this question, what is given? It is given that a rod of length 10 centimeter lies along the principal axis. The rod is lying. It means the horizontally length is given, and it is in front of the mirror. As you can see that it is written that concave mirror, and the focal length is 10 centimeter is given to you. This is your mirror, concave mirror. This is your rod basically. Here you can see that the rod is assumed that is AB. So AB is your rod, and the length is 10 centimeter. And it is given that in such a way that the end closer to the pole is 20 centimeter. It means this is the one end B of the rod, which is 20 centimeter from the pole of the mirror, and it is asked to determine the length of the image formed. So what should we do? As I have told you that whenever we have to draw the ray diagram of any object, then basically we consider one point of the object and take two rays away from the object, and after reflection or refraction, the two rays intersect to each other and we get the point of the image. Because here the object is not in the vertical position, means if the object is like this way and your mirror is like this way, okay, so one point is taken as here and two rays, one is uh, parallel to the principal axis, other at certain angle like this way, and we get to the intersecting point at a position and the point becomes the point of image. But in place of vertical object, in this question, the object lying on the principal axis like this way. This is one terminal A, this is your second terminal B, or end terminals we can say, and the length is given to you 10 centimeter and one end is closer to the 20 centimeter from the pole. Okay, so the concept is that now, because as we see in case of the vertical object, then whether it is A or B, both points lies at the equal distance from the mirror. Okay, so this distance with either calculated for point B or for A, the distance is equal. But if the object is lying on the plane, then the point A has a different distance and the point B has a different distance from the mirror. It means now we are in need of taking 2 points in place of 1. It means we have to calculate the point of image for point A as well as point of image for B. Now for point A. For point A, apply formula. Formula is 1 upon f equal 1 upon v plus 1 upon u, because this is a mirror. Focal length is given to you, that is 10, and it will be negative, as you know. Okay, so 1 by v, and that is va. Let be the image point of the point A, plus 1 upon u is, that is, minus 30. As you can see here, this is your 20 and plus 10, because A point is 30 centimeter from the pole, so it will be minus 30, or we can simply write minus 1 by 10, that is 1 upon VA minus 1 upon 30. Okay, so we have what we have, 1 upon V equal 1 upon VA equal 1 upon 30 minus 1 upon 10. Okay, 1 upon 30, it is negative, so on the other hand it will be positive. 1 upon 30 minus 1 upon 10. Okay, now take LCM. Let LCM be 30, so it will be 1 minus 3, or 1 upon VA. So 1 upon VA, and that will be your minus 2 upon 30, or we can say VA, that is equal minus 15 centimeter. It means we can simply say that if this is your mirror and this is your we can say this is your point A, which is 30 centimeter away from the mirror, and then we have the image point A dash. This is A dash, let's suppose, and this is the 15 centimeter from the mirror. So this is the position of the point A of the object. Now in the same way we will discuss about the point B. So as here for point A, in the same way now for point B. Point B. As you can see in the diagram, point B is 20 centimeter away from the mirror. So we will draw a diagram like this way. This is your mirror, concave mirror, and this is your point B, which is 20 centimeter away from it. Okay, now again apply formula. 1 upon f equal 1 upon v plus 1 upon u. So that is f, and f is given to you, that is minus 10. So according to sign convention, so it will be v, and u is minus 20. So it will be minus 1 by 10 equal 1 by v minus 1 by 20. So 1 by v equal 1 by 20 minus 1 by 10. So basically if we take LCM 20, so it will be 1 minus 2, 1 by v. So v equal minus 20 centimeter, and that is for point B. So let it is B, B, and finally this will be for point B. So B is the point of the object, and we get the image of the point B, B dash, which is also at 20 centimeter. So finally we get a result. What is the result? The result is this, that you have a mirror like this way. You have object having point A and B like this way, and the point A is your 30 centimeter apart, point B is your 20 centimeter apart, and for the images of these 2 points we get the image of point A, that is your A dash, here A dash, and A dash is at 15 centimeter. So it is your 15 centimeter, and B dash it itself at point B, so it is your 20 centimeter. So what are the final points of the image? So points of image are a dash and b dash. So this is the length of your image. So what is L? L is nothing but you can simply say that that will be b dash minus a dash, or we can say that v of b dash minus v of a dash, and b dash. So uh, VB dash, sorry, VB dash. So VB dash is your here, that is minus 20. So it will be minus 20 minus, and VA dash, this is minus 15. So it will be minus 15. So minus 20 and plus 15. So it will be minus 5 centimeter. So I hope and I believe that now the question is clear to all of you. Okay, this is your next question, and this is question number 3. We will continue our journey of the numericals from the book S. C. Verma, The Concept of Physics. And I will try to explain each and everything to you, but for that you have to join me, you have to associate me. Okay, so I will try that you will feel more comfortable in physics. And once again I am saying that please and please try each and every question by yourself, then you can see my video or solution. Okay, thanks for watching me, thanks for listening me. This question and more question we will discuss in the next lecture. Thank you.